Hello, my name is Roy Simpson. I'm an instructor of mathematics at Cosumnes River College in Sacramento, California. This is the second part in a lecture on equations of lines for an intermediate algebra course. We had just finished our discussion introducing the slope-intercept form of a line, and now we're going to go ahead and graph linear equations given in slope-intercept form. It should be somewhat quick, so it's very easy to graph equations given in slope-intercept form. So this is another reason why it's a very strong form to have your linear equations in. So we'll start this with a simple example. I'll give you a linear equation that when graphed goes through y-intercept of -8/5 and has a slope of 3/5. So let's go ahead and graph that. That's part of our question. And then we're going to write down the equation for that graph. And then finally, we're going to look for the x-intercept. We're going to try to calculate what that is. The y-intercept is pretty easy, but the x-intercept is what we're going to concern ourselves with, just to switch it up. Here we go. Let's go ahead and plot a point or two. Let's see, I happen to know the y-intercept here is a -8/5. Remember, that's what b is. They're telling me the y-intercept occurs at a -8/5. So I'll go ahead and plot that. Remember, y-intercepts occur when x is 0. And a -8/5 is almost down to a -2. So I'll plot it right down here. And then I'm going to use the slope to go ahead and get me my next point. Now there's two ways to do this. A lot of people learn that they go up, because they tell me the slope is 3/5. A lot of people think, okay, that forces me. I have to rise 3 and run 5. You can if you want to, but the fact is, I have a fractional y-intercept, which is kind of a pain to work with. So I'm going to use the slope addition property, which, recall, says that if I increase the x value by 1, and right now we're standing at x equals 0, y equals -8/5. If I increase the x value by 1, then the y value will change by the slope. So if I'm standing right now at 0, -8/5, and I increase the x value by 1, well then all I'm going to do is add the slope to this y value. Well, currently the y value is -8/5. Adding 3/5 to that will get me to a -5/5, or in other words, a -1. So that's just a very nice way that you can use the slope to determine your next point. I would probably use the slope addition property, especially if I knew that the denominators were the same and they're both fractions. It's a very nice indication that you should use the slope-intercept or the slope addition property. Otherwise, you could say I rise 1, 2, 3 and run 5. Okay, but let me connect these dots here, and we'll just try to do this as exactly as possible. It's kind of difficult freehand. We'll see what we get here. Now, because I'm doing this freehand, it won't be too exact, but I do want to demonstrate something. Had we done the rise by 3, run by 5, that means I would have gone up 1, 2, 3 units. I would have landed somewhere around here, and then run over 1, 2, 3, 4, and 5. So obviously my graph is not perfect here, and that's mainly because of the fact that I'm graphing by hand. So really it should be a little bit lower, but close enough for government work, right? So there's the graph of it, and now we want to know the equation of this line. So let me go ahead and change pen colors for that. The equation, I could do several ways, but I'm going to do it just in the y equals mx plus b form, or in other words, the slope-intercept form. They gave me the slope, they gave me the intercept, so that is going to be y equals the slope, 3/5, times x, plus b, and b is a -8/5. If it was a +8/5, I would have written plus 8/5. So there's the equation, that's part B. And finally, I ask you for something odd with this problem. I ask you for the x-intercept. It'd be very easy if I asked you for the y-intercept. That's just -8/5. But the x-intercept occurs, well, when y is 0. If you look at the x-intercept, it's where you hit the x-axis, and that point has something very special with it, the fact that y is 0. So to find the x-intercept, we're going to let y equals 0. So you get the 0 is equal to 3/5 times x minus 8/5. And I have an equation. This is something I've mentioned in a very, very previous lecture, a lecture a long time ago, that when I have fractions in equations, I have the opportunity to multiply both sides of the equation, by a number that will get rid of those fractions. You can only do this if you have equations. So I'm going to multiply both sides of this equation by the LCD of all the fractions involved, which is just 5. It might not save any time, but the fact is I just don't like working with fractions, so I get rid of them as quickly as possible. 5 times 0 gives me 0. And on the right-hand side, that 5 distributes to each of those fractions and cancels with their denominators, so I get 3x minus 8. And now I'll go ahead and add 8 to both sides. And I'll divide both sides by 3. So I see the x-intercept occurs at 8/3. 8/3, comma, 0. Now, because I graphed it by hand, it might not be a perfect 8/3, and in fact it's not. 8/3 is, well, actually, it's pretty close to 8/3. 8/3 is just shy of 3, and look, that is just shy of 3, so that's pretty good. No, yeah, it is. That's pretty good, actually. All right. Now let's go ahead and use these skills to start graphing just a couple more equations. Graph y equals 0.25x minus 4. Now in this situation, there's a couple options. You can stick with decimals if you want, or you can change this to a fraction. I personally like sticking with fractions, actually, changing to fractions, than sticking with decimals, but it's a complete personal choice for you. In either case, you'll get the same graph. So let's go ahead. Actually, I'm going to change colors here so that it's a little more apparent. I know that this is my y-intercept, -4 is, so I'm just going to go ahead and plot that. It's right here. And this would be my slope. Now, if I don't write it as a fraction, it gets very difficult to do this problem. I could use, if I leave it as a decimal, I could use the fact that the slope addition property tells me, oh, if I start here at -4 and I just increase the x value by 1, my y value will change by the slope. Or in other words, my y value will increase by 0.25. That's horrible. So if I did that, I could do that. It'd just be that my y value would go from -4 to -3.75. You could do that if you want. A better idea, again, like I said, is just to change this to a fraction, a skill that I don't need to talk about. If you do that, then you know the slope is 1/4. So starting at my y-intercept, I'm going to go up 1. Let me do a different color for that so that you can see this. So starting at the y-intercept, I'll go up 1, and I'll go over 1, 2, 3, 4 steps. That'll be my second point. I'll label both these points because I have a bad habit of not labeling my points, and that really is a bad habit. That's x equals 4, y equals a -3, and this is x equals 0, y equals a -4. And if you connect those dots, that should provide you with a nice clean line. And there you have it. Don't be lazy with your lines, by the way. Don't just make them go a centimeter beyond the points on both sides. Go a little bit further out. So there we go. We've graphed that one. As a final example in this section, or in this part of this lecture, we'll go ahead and graph something that has a fractional slope that's a little more challenging. -3/13. That's our slope. Here's our y-intercept. Again, using the fact that y equals mx plus b is a beautiful format. The coefficient of x is a slope, and the constant term is the y-intercept. So I'll go ahead and start by plotting the y-intercept. You should always ask yourself, what do I need to graph a line? Well, 2 points, and one we just found. One is at x equals 0, y equals 7. To find the second point, you use the slope. I would not use the slope addition property here because I don't want to just move forward in the x value by 1 and then drop my y value by 3/13. That's a horrible choice, actually. In this case, I started an integer value for a point. I would love to just drop 3 units down. 1, 2, 3 units down, and then run by 13. By the way, that negative says drop down 3, but the bottom is a positive 13. So the bottom is saying now run forward 13 steps. 1, 2, 3, 4, 5, and so on and so forth. This is all the way out to 10 there. And I'll need 3 more steps beyond this graph. So 1, 2, 3. We'll just say it goes to there. And you connect those points. By the way, this is at x equals 13, y equals, let's see, we were at a height of 7, but we dropped down 3, so this must be a height of 4. And you connect these lines, or these points, sorry. Sorry that it's not perfect, but I've got to figure a way to do that right. Some people ask, and rightly so, I think it's a good question, well, what if I wrote it this way? Well, I have 2 statements. One, that you shouldn't write negatives in denominators. It's just bad form. I've repeated that in the past. But 2, you're not at a loss here. You're still okay. What this is saying when you read the slope off here is, well, starting at a height of 7, I'm going to go up. Remember, rise over run. So up by 3. 1, 2, 3. And then back. In other words, left 13 steps. So I'll go this way 13 steps. When I do that, I'll get a point that also exists on this line. So either way, you could do it either way.